Hello everybody. This video will deal with actual data transferring from a satellite to a receiver or any transmitter to a receiver. So let's describe the problem. Is that we have a transmitter sitting over here. It's going to communicate to a receiver some distance away. Now, one thing we know about this channel or this path is that it's noisy and unreliable. Is that sometimes there will be signals there and sometimes they won't. So what we have to do is design a protocol that, number one, we know we're taking errors on this receiver, and number two is we know, or we have a way of the ground station communicating in a reverse direction to tell the transmitter which ones it missed and to retransmit. So let's talk about one way to do this. First of all, there are many ways. There are many protocols, and some are optimum for space communications, and some are optimized for fiber or terrestrial deals. And I'm gonna describe one that's used in space. And I make no claim that this is the best one, but this is one way to do that. So if we have a file of several thousand bytes, we're going to want to break this up into smaller chunks, and these chunks we break it up to are called packets. And packets are composed of just several bytes grouped together. Now, one of the things that that receivers or modems need is if when they're turned on, the data stream is flowing, they need to know when to start. What is the start of the packet and what's the stop? And sometimes they need bit patterns to get what's called synchronization. So one way to do that is to break up these files into sub files or smaller divisions called packets. And the way to synchronize the packets is to start each packet or each frame with a known bit pattern. This known bit pattern we will call the sync or framing bits. Now, if we're gonna take a large file and break it into smaller chunks, if we take a data dropout, if we can identify which chunks we missed, then we can retransmit these and repeat and fill in just what we met. So one way to do that is after we send the framing or start of frame bytes, the next thing we will send is perhaps the total number of packets we plan to send. And then if we number those packets, if we fail to receive one of those packets, then we can say, send us just a small piece of the file rather than sending the whole piece. Now, how do we detect errors? Well, one of the ways to detect errors is the data, with the actual useful data, which we will call a payload. And if we take that payload and by some magic add some extra checking bits, some parity bits, is that we can determine if there were any errors received in this payload. Now, one of the ways to do that is called a CRC, a cyclical remainder checksum. And what we do is we take this payload that might be composed of, say, for example, 64 bytes, divide that by a known polynomial. That will produce a remainder. So if we send the payload and the remainder, this remainder can tell us, all right, so we transmit the payload and the remainder. The receiver receives the payload, divides it by this polynomial, and compares the remainder. If the remainder's compare, they exactly equal, we can be relatively assured that the payload is accurate. And if this CRC is long enough, we can be 100% assured that there are no errors in here. And typically, but now as we add remainder bytes, remember that reduces our throughput. So there's a compromise. So we might want to say we want to be assured that we will catch only allow one error to get through in every million bytes. That might be acceptable. And it's beyond this video to explain how long or which polynomial has to be. But if you go to Wikipedia and look up CRC, there's a nice description about how to decide what this polynomial is and how many bytes you need to send in this remainder checksum to guarantee the error rate you want in your payload. So now let's review what might happen. Let's assume that we're going to send maybe a file that's got 1,000 64-byte packets. So we would start every 64 bytes of payload. We'd start with some framing or sync bits. Then we would say the number of bytes in this file, which in this case might be 1,000. And then we will start to number the payload bytes. So the first 64 will have byte 1. The next 64, this thing will be incremented up until we get to 1,000. So now the ground station, the first information he sees, hey, look, I'm looking for 1,000 of these packets, and now I've got the first one here. So the ground station will take this payload. First of all, he'll strip off these framing bytes. He'll strip off these information bytes, and he will take this payload here, and he will then divide it by this this known polynomial. He will take the received remainder, compare it to his calculated remainder, and if those two check, then he can be relatively assured that his payload is correct. So, for example, if during the middle of the transmission he misses packet 500, at some point the receiver, the ground station will transmit back to the satellite and say, look, I missed packet 500, resend packet 500. So this is one method of which satellite communications can take place.